All right. So DeMorgan's law is a way of simplifying logical operations. So you probably used simplification before in like maybe 7th grade, 8th grade, maybe freshman algebra. And for some of you, because you're like rock stars, you started, algebra in 4th grade and you're gifted and talented programs or whatever. But when we distributed things like 4x and 6x, we took 4 times 4x, getting 16x, and 4 times 6x, getting 24x, and then we added it together. Then we could add the 16x and the 24x and get 40x and say 40x equals 400. That initial equation looks impossible to solve, right? But the simplified equation you can do in your head. So simplifying logic in the same way does make it easier, but of course it's computer science and everything has to be more complicated so we can get paid more. But the simplification through DeMorgan's will help simplify logic operations. So the basic principle of DeMorgan's law is you can distribute the knots and flip things. So here's the classic DeMorgan's law, as it's called. So if you had an A and B, so let's say A was true, B was true, that would evaluate to true. With a not, it would, flip it. Or you could flip it, not A, and then flip the sign and not B. So it's a way of distributing and doing the opposite. That may look complicated, but once you get the hang of it, you'll see why this is easy. And just have some faith in me. This is just the initial. That's DeMorgan's law summarized, the way you often see it summarized in textbooks. But what we have to do is the opposite and get the hang of flipping your operators. So the opposite of equals or equals is not equals. So hopefully that one's easy. Now it gets a little trickier. Less than's opposite is greater than or equals to. Do you see the difference? Less than's opposite is not greater than. It's greater than or equals. So hopefully you caught that. Greater than or equals opposite is just less than. So do you see the way it kind of, you have to be aware of that equals to make it make sense. And we're going to practice that in just a little bit. And's opposite is or. So if a statement is originally and, we're going to flip it to an or. And remember, and in Java is symbolized by ampersand, or that symbol above the 7. And the or is what we call pipes, or those lines that are right above the enter key. So, and 2 of them are, as a lot of people call them, the pipes. This is just a summary of what we just did in those slides from a textbook. And as you can see, the textbook, literally from a textbook, DeMorgan's law. And usually there's one, if not more, but usually one DeMorgan's a problem of the 40 multiple choice problems you'll be given. One of the problems will be easiest, so you can solve without DeMorgan's, but is easiest solved using DeMorgan's. So this is a 1 question lesson, but it's kind of cool too. It's just the whole thing is kind of fun. So what I'm going to challenge you to do before we start doing some of these equations on paper is I'm going to challenge you to go into your Google Classroom. And inside of Google Classroom, there is an activity called Code Tracing Practice that's near the top. And I'm going to ask you to open that up and just practice getting, oops, I gave you a free one. Wait a second, that's not the right one. Oops, just 1 second. That's our old one. Let me put in our new one. My apologies. Please stand by. I can't believe I didn't do that. Mr. Rhodey. Again, my apologies. It should appear in Google Classroom any second, called Unit 3, Topic 6. Sorry about that. My sincerest apologies. And what Unit 3, Lesson 6 asks you to do is, oh my gosh, is just do the opposite. So, for example, what is the opposite of equals? Well, the opposite is not equals. Oh, geez, no wonder I did it wrong. Not equals. So what you want to do is you want to go through those and make all the opposites and just practice those opposites. If you need to refer back to the slide deck, that's fine. When you have that done, would you mind, please, going done into the chat window for me so that I know you are done. Great job, folks. And sorry about that, line 5. I got to fix that. Line 5, which is actually line 4, sorry, here. Line 5 on the spreadsheet, line 4 in our project is actually wrong. It should just be greater than. Less than or equals to opposite is greater than. So applying Morgan's law is these two are the classic ones. It would be not A or not B. For this second one, it would be not A and not B. Those are just the classic Morgan's law prototypes. But what does that mean when we apply it to actual logic problems you'd have in your Java programs? That's what this problem is designed to show. So what I'm going to challenge everyone to do is get out that paper and pencil. And what I'm going to ask you to do is write down the problem. Int A gets 5, comma, B gets 4, semicolon. And then write down that expression, not A in paren, A less than 0 or B not equal 4. And actually write that thing down. I know that's hard to see, but actually write that down on your paper. When you have that problem actually written down in real life, physically, could you raise your hand so that I know you are actually writing it down? Thank you for, oh, thank you. I love seeing all those hands go up. If you need to run and get paper, go ahead. I won't yell at you. Nice, nice. Actually physically write it down. I know that's challenging because we're going to actually physically solve these problems like on paper and pencil. Isn't that freaky? Some people, I assume, are just getting paper. And it's hard to find paper and pencil in 2020, isn't it? Don't write on toilet paper. That stuff's way too valuable. Awesome, awesome. All right. What we're going to do next is actually solve the problem. And the way I propose you, and we're going to solve it, I'm going to ask you to write this out. The way we're going to solve it is a multi-step process, just like you would do in algebra. So, and maybe this would be helpful if we did it just step by step so I could show it to you. Oops, sorry, struggling. The first step, we call it the flip step. So with the flip step, or DeMorgan's flip, whichever you want to call it, what you're doing is you're taking that A less than 0 and you're flipping it to A greater than or equal to 0 with the opposites. Remember that whole opposite thing that we did, the yin yang, the little activity we did on the spreadsheet? Well, you're going to take that and you're going to flip it. So it would be A greater than equal to 0. And then the or, notice the or in the original now flips to an and, which, by the way, I have a hard time writing those on the board. And now you're going to see I have a hard time writing them in paper too. And then the B goes from not equaling 4 to equal 4. So that's the first step. And I encourage people to either write out these steps or to write and erase. It's like when I do this on the whiteboard, I actually make this line and then I write the next line, which is substituting the A and B values. And I rewrite. Now, some of you probably could just erase and get away with it. That's absolutely fine. But so now I rewrite. And then the next step is one of the solve steps. Sometimes you have multiple solve steps, especially if you have a prolonged expression. But for this one, 5 greater than or equal to 0 is true. 5 is greater than or equal to 0. Oh, I love the way I spelled true, like true value. 4 equals 4 is true. So true and true, as you remember from our exciting game that wasn't Among Us, even though that's what you all voted for. Sorry about that. I was the imposter. Is true. So that's an example of how you solve a DeMorgan's problem. And often on the AP test, they give you problems that are best solved using DeMorgan's. So it's a kind of a handy tool to have. It's super handy if you're applying for a job at a place like Epic too, so where they give you a logic test. And using DeMorgan, I was able to break down these problems and I had some confidence I got them right. There are some people who will solve this on their own, which you could do. And you could solve it first solving this or this, and then flip the whole result. So you can do that, or you can do this. DeMorgan's is encouraged. And sometimes they ask freaky questions about like which of the following correctly applies DeMorgan's law, which really forces you to know DeMorgan's law. But often it's just a logic problem to solve. All right, but wait, there's more. Can you please solve? First, write it out, and then solve this DeMorgan's problem. And what I'm going to ask you to do is when you have it solved, would you mind lowering your hand? So right now your hands are up. When you have it solved, would you mind putting your hand down? The answer is a true or a false. So you have a 50-50 chance. All right, I'm going to just go over the answer. Oops. By removing this poor kid whose rocket is in front of the answer. Whoa. Okay, I actually misflipped my symbol. I would have got it wrong. So first step is that DeMorgan's or flipping step, where we go B not equal to 3. We flip the or, and then A, instead of less than, it's greater than or equal to 1, which, by the way, I misflipped that right there. So 3 not equal to 3, or 2 greater than or equal to 1. Then we solve it. This is false because 3 is equal to 3. It's or, and 2 is greater than or equal to 1, true. And in a classic or statement, the grandma statement, as long as one value is true, the whole thing is true. And I'm glad that's not on my epic test today, because 50-50 chance and I get it wrong. Wow.
I have a question.
Yeah, please. Thank
So
you.
the exclamation mark is outside of the parentheses over everything, but why is
Yes.
it not put in front of the A as well?
I get exactly what you're saying. Let me demonstrate why the theory behind this. And I wish I had a board because that's such a great question, Jason. So what you're actually doing is for each expression, consider this a rewrite of the expression. I'm going to change the font here just to make it bigger and easier to see. This is one of the expressions. This is like a thing we're going to flip. And this is a thing we're going to flip. And what you're actually flipping is each one of these. You're flipping the whole Boolean, not every character in the Boolean, which is why I get totally where that source of confusion is because of like this, where they're saying A, not B, what they mean is this whole expression. So this true or false expression, this true or false expression. So I get totally where you're coming from. And that textbook example really confuses people. But what you're actually flipping is this. So the flip of that is actually B equals 3. The flip of this, the not of that, is that. And the not of this is A greater than equal to 1. So Jason, that is the greatest question, because the example makes it look like you flip every single character. So like not A, flip this, not 1, right? But instead what we do is we flip the expression. Each Boolean expression or operator in this case is flipped. Did that clarify it or confuse it, even though that was such a good question?
I think I understand it.
So each one of those, each one of these is an expression that gets flipped. And this gets flipped. So that's where the flips come in. Talk about challenging. And this law that they give just is ripe for confusion, especially when I use A and B. Maybe I should change it so it's X and Y just to prevent that confusion right there, because it is, I totally get it. I totally get it. In fact, that's so good. I'm going to leave it in the lesson. Great one. All right. Ready for the next? Oh, there's 2 here. Oops, that's not what I wanted to do. Let's just do one at a time. So I'm going to block one of them out. Wait, is that the one we just did? Huh. Okay, that is the one we just did. Don't do the result 1. Now do result 2. So would you mind writing down result 2? And then when you get result 2, would you mind raising your hand up so that I know you are done? So we'll do result 2, and let's hope I get this one right, huh? All right. So on this one, the first we do the flip. So with that flip there and the flip there, Notice the 2 does equal 2, and 3 is 3 is not greater than 4. Yeah, okay. Phew. True and false results in a false. So hopefully that's getting more, making more sense. Just a fun, I don't know if you want to call it trivia about DeMorgan. DeMorgan is the person who came up with this, and it's obviously very useful in computer science where we do a lot of Boolean logic, and there is a picture of DeMorgan. Have a video to watch, but we're not going to watch the whole video. We're just going to watch it from 449 because I think it's interesting to hear about why this is useful. We just did a lot of work on paper, and you're probably like, well, what? It's just good to see what it's useful for. And I thought the AP did a good job of explaining that. So we're going to watch that just from 449. We're not going to watch the whole thing.
So let's put it all together. Here's a common mathematical expression. You may have solved in math an inequality and come up with a solution, something like this, where x is less than -5 or x is greater than 10. And here it is graphed on a number line, right? So less than -5, it goes to the left, and greater than 10, it goes to the right. Open circles because it's not less than or equal to or greater than or equal to. And here's how we'd write that expression in Java. We would say x less than -5 or x greater than 10. It's not and, because that's to be one or the other, because it's two different parts of my number line. But what would happen if I'm looking to negate the expression? Basically, what is the opposite of x less than -5 or x greater than 10? If you look at the number line, it's this portion right here. I want all of the stuff inside the 2 blue arrows that I currently have. How do I do that? Well, I'm going to negate it. So when I negate it, can I use DeMorgan's law? Sure. So here is not x less than 5, x less than -5, or x greater than 10. What happens using DeMorgan's law? I distribute the negative, or distribute the not, and I flip the or to an and. So not x less than -5 and not x greater than 10. Now what happens? Well, when I distribute the nots to each one of these, this becomes x greater than or equal to -5 and x less than or equal to 10. So when I distributed the not, the less than became greater than or equal to, and the greater than became less than or equal to. So these are equivalent expressions. When I negated my original expression and I applied DeMorgan's law, I could say x is greater than or equal to -5 and x is less than 10. And if you think about that, that covers all of the area that's currently not shaded inside of my number line. And that's how DeMorgan's laws work. So what should we take away?
All right. I feel like I hope it's so hard to tell virtually. So I'm going to ask for a rating scale. If people wouldn't mind putting in the chat window. 10, 1 if you're lost, and 10 if you got it. And I'm going to ask that you rate your personal level on a scale of 1 to I'm lost to 10, I got this. And if you wouldn't mind just putting that in the chat window so I know how many more of these to do. We do have one more topic in today's lesson. But I don't want to, I just want to see how people are feeling about this. I love the 8.5, 7.5. You folks have a great sense of humor. Peyton, 9.9. He doesn't want to claim expertise, but he's there. He's getting there. I love that. Well done. Good, good, good. Well, we're going to just ask one more then. One more DeMorgan's law. And I'll just pick the last one in this series. And notice it's added a system.out.println line. So you could actually code this one, and the answer would be a true or a false. So would you mind doing this our last problem for today?
Our screen's still in the video.
Oh, I bet you're wondering like what that last problem is. Thank you, whoever was brave. If you wouldn't mind lowering your hand too once you have the answer, now that you can actually see the problem. That probably helped. Yeah, I'm working away at it. I got a head start. And feel free to just lower your hand when you get it. Some people are still finishing up, but I'll show you the first step. The flip step. After you flip it, you do the substituting. Ah, unless you're Mr. Rhodey. Wonder how I did this. Did I do it in 2 steps here in this version? Nope. So hopefully that's making some sense, and you'll be able to use DeMorgan's law to solve those logic problems when they come up. The next topic is a best explained by video, and again, they do just a better job of explaining it than I could. So we're going to watch one of those AP videos. Oops. Here we go. Just so if you're wondering, it's 6 minutes. So.
Hi, everyone. Welcome to AP Daily. My name is Tim Gallagher, and I'm an AP Computer Science teacher at Winter Springs High School, located just outside of beautiful Orlando, Florida. Today, we're going to be discussing topic 3.7, which is comparing objects. And in this first of 2 videos, we will be comparing object references to identify aliases and null objects. So what will we learn? As I mentioned, we're going to be comparing object references using Boolean expressions, and we are going to look at how two object references are considered aliases when they reference the same object. And we're going to be using the double equal sign and not equal signs to identify those. And we're also going to be using them to compare against null values. So let's look at an example. Here I've got a class called house. It's just a basic class. Notice it has 3 attributes. It's got a color, square feet, number of bedrooms, and then there's a constructor, and I'm using my constructor to initialize those variables. And there could be other methods and things like that that I'm not looking at. But for right now, this is the basics that we need to know about this house class. So I want to consider these object declarations and constructions. So how many object references do I have here? Well, if you look at where it says house, my house, Anna's house, Bob's house, and house, mom's house, those are my 4 object references that I've declared. So I've got 4 object variables. And then how many objects did I actually create? Well, we go over to the right-hand side. And here, when I said my house equals new house, and it's a greenhouse, 1,850 square feet and 3 bedrooms, Anna's house is also a greenhouse with 1,850 square feet and 3 bedrooms, but these are separate objects, right? It's just like if you go into a neighborhood and you see 2 houses that are the same color and same size, same number of bedrooms, but they're completely different houses. That's one's my house, one's Anna's house. Bob's house, it's just a variable, hasn't been constructed yet. And then mom's house, I set it equal to my house. So what happened there? I didn't actually create a new house. I just gave my house another name as well. Now my house can also be referred to as mom's house. Let's look at a picture of this to represent it a little bit better. So here are the same declarations that we just discussed and constructions. My house is an object reference that contains the address of this house object that we just created and all the attributes, the color, the square feet, and the number of bedrooms. Anna's house contains the address of this object that it just created, color, square feet, number of bedrooms, identical, but it is a separate house. Bob's house, we didn't do anything with it, so it's null right now. But then mom's house contains the same address of that my house refers to. So my house and mom's house refer to the same singular house object. So what we have here is that my house and Anna's house refers to 2 separate objects with identical attributes. My house and mom's house are aliases, just like an author writes a book under a pen name or a pseudonym, same idea. One house, 2 different names. And then Bob's house doesn't reference an object at all. So how do we identify those using a double equal sign or a not equal sign? So here's some code. I've put my declarations and constructions in this code here. And now I'm going to use an if statement and use a double equal sign. In this case, I say if my house double equal sign mom's house, then it'll print out these are aliases for the same house object. And they are. We saw how my house and mom's house refer to the same single house object. A double equal sign will identify that alias. But what about if I say if mom's house is equal to Anna's house? Now you might say that, well, they look the same. They contain the same color, same square feet, same number of bedrooms, but they're not aliases. These are 2 different objects. So this will not evaluate to true. This will evaluate to false, and it will print out these are 2 different objects. Likewise, what if I say use the not equal sign? And can I say, is it true that mom's house does not equal Anna's house? Well, what is mom's house? Mom's house is just another name for my house. And they are not the same object. They're 2 different objects. So this will print out that these are 2 different house objects. They're not aliases. Mom's house and Anna's house refer to 2 different house objects. Let's talk about null. So I can use the double equal sign to check for null. So in this case, Bob's house. If Bob's house is equal to null, which it is because we never constructed it, we never said equals new house, this is going to print out Bob's house has not been constructed yet. It's still null. We could even check not equal to null to see if a house has been constructed. My house has been constructed. So if I check to see, does my house not equal null? Well, that's true. It does not equal null. So it's going to print out my house has been constructed. And that's how we can use double equal signs and not equal signs to check for aliases and to check for nulls. So what should we take away? Well, we've been comparing object references using Boolean expressions. We know what aliases are. It's when two references considered aliases when they refer to the same exact object. We use double equal signs and not equal signs to identify those aliases. And we also use the double equal sign and not equal sign to determine if objects are null, if they actually reference an object. That's it for this lesson on AP Daily. Thank you so much.
You're muted.
Man, I'm riding the struggle bus. Thank you, whoever let me know I was unmuted. That was a huge favor. Really appreciate it. That was a great explanation of how the equals works with objects. Now, remember with primitives, equals works like you'd expect. So feel free to use equals with ints, doubles, booleans, works great. With objects like string class is it's not going to work. That's why we use the dot equals. So if we want to compare, like a classic example is the password program. This password program here is buggy. It's not going to work like you expect it to because of the explanation you just heard about objects. Because strings, notice the capital S, a string is a object, not a primitive. So if I set a string password to 1234, and then I do a scanner where I say, hey, boy, this code is back. No, it's not. It's perfect. System.out.print password, and then it takes in a user guess and puts that into the variable, the string variable user guess. And I say, hey, if user guess equals password, access granted. But just like the different houses might have the same number of bedrooms, same color, and same number of square feet, they by all appearances are equal, but they're not referring to the same object. That's what equals means. So in this particular case, for strings, they wrote a special dot operator that allows you to compare the values of the characters inside of the string. So this code is buggy. It wouldn't work as you'd expect it to. The code that would work, shoot, I should have said that. The code that is not buggy, that would have worked for this exact same process, that would have been perfect, would be to say dot equals and then put in that password. And this would be perfect. This code would work and behave like you expected because it has a dot operator called equals that checks to make sure the password matches. So if you are struggling with DeMorgans, CS Awesome has some great additional practice problems for DeMorgans. Feel free to do those. Feel free to read the explanation. They even have a video that explains it, especially if my explanation just wasn't doing it for you. There's other explanations out there on the internet too. This is a big topic. There's all kinds of videos. I was going through them when I was planning this lesson and just decided to lecture it out. But again, try to get this DeMorgan's principle and practice it. I'm going to end class, a little early, by begging you to get stuff in that needs to be turned in. So I'm going to go to this tab and I'm going to just ask that's future assignments, that you complete the following tasks. And the way I'm going to indicate this is I'm going to edit and add little asterisks to let you know that these are assignments that need to be turned in that I'm grading. So these items, we still have half of those out, need to be done for a grade. And it's this is actually a gift to give you a grade for these things because it will improve your grade. And this big project, the twist-a-plot, is the big one. So if you can get that done, that would be awesome too. You really only have to add, I don't want to sound, I may have presented the task a bit overwhelming. You only have to do like one thing because you only, or maybe two, you only need to have I forget the exact criteria, but it's like 4 if else's. So you only need 3 if else's. So it is a pretty easy assignment. I'm not asking you to design a big, huge story. You can just go one direction, not the music group, but you can just go basically one thing, a north, south, east, west, and you've got your 3 if else statements. It's not a tough one. Just keep in mind that you can't go equals equals. You have to go dot equals. And there's even an example there. So I'm going to leave you with these 10 minutes to finish up all these assignments that are in Google Classroom for the Boolean unit. We're not going to have a test on the Boolean unit yet. We're going to have a test on the Boolean unit. Unlike the previous plan, I don't know if I shared it with you, but we're not doing a separate test for Boolean. We're saving it for the 2 days before the holiday break. And we're going to do a project instead of starting classes and stretch it out and give you opportunities to improve your grade. If you notice, there are 3 assignments and they're of the same value that the 2 assessments are going to be worth. So it's almost like the assignments are worth almost, or sorry, there's 4 grades for the assessment. So the assessment is worth 3, the assessment is worth 4, the assignments are worth 3. This is a chance to really boost your grade and help things out. So please get those things done. I'll stay online to answer any questions people have, and I'll be the last one to be end this meet. If you don't have any additional questions, class dismissed. Greetings is, oops, I'm going to stop recording.